Okay, welcome back to my series as I break down the different types of CMM sensors that you might run into on your modern day CMM. Previously, I've broken down the chromatic white light sensor and the camera sensor or vision sensor. And this week, we're going to go over one that a lot of people really like, a lot of people have a lot of questions about, which is the blue light laser. So let's drop off that camera sensor that we talked about last week back into our probe rack here, and let's grab our blue light laser here on the right, and we will dive right into the benefits of why you might look at adding or using a blue light laser on your bridge CMM. So the blue light laser is a very, very fast non-contact sensor. It allows for 3D measurements, creating point cloud data that can be used to recreate CAD models or just gather a very large amount of data in a very short amount of time. It is great for capturing profile and complex shapes. However, it is a lower accuracy type of sensor compared to something like, let's say, the chromatic white light sensor, but it has a much larger field of view for more data collection. You'll see how fast it's moving. I just am going to be looping this video here. It's really commonly used in sheet metal applications as well as castings to measure shapes that may be too rough to use with a tactile sensor or a styli of some sort. But as you see on the screen and as you've probably already noticed, you can be using this sensor along with the other non-contact sensors that we've already talked about. You can store it in the probe rack, and it can be used on an articulating wrist to get different angles of a part. So let's talk about some common applications that we would see the blue light laser be used. The primary one is going to be those sheet metal applications. I mentioned it here. We have, let's say, a body automotive frames and panels. Can also be used for aerospace structures, electronic housings, and appliances like bodies of refrigerators and washers and things like that. I also mentioned castings and forgings are another common use for the blue light laser. Just due to some of the shapes and organic shapes that you might see with certain types of castings, as well as the rough surfaces and the complex geometries that you could achieve. As well as making it easier to collect a large amount of data that could be used for datum targets on your drawing rather than having to come in and collect individual points with a tactile probe. Speaking of which, the aerospace and defense world would use the blue light laser for things like blades and fins. It can also be used for plastic parts and plastic devices. Anything where you're going to be capturing a lot of different dimensions, both 2D and 3D. It can do that very easily, especially when you're dealing with lower accuracy type of applications. And then we also have the medical world using the blue light laser, especially for anything where you don't want to scratch a part and avoid any sort of bacteria buildup or anything like that, such as medical implants. So because the blue light laser is a bit unique, I'm going to talk a little bit about how it works. Essentially, we are using a laser that is going to be coming out of the probe body in a controller. It is going to shine down onto the part, and we have a sensor that is reading where that laser is on the part and essentially triangulating its position in order to gather a bunch of information very, very quickly. So some specs about the laser is that it is less accurate than many of the non-contact sensors that we've already talked about. It has a form accuracy of about 8 to 12 microns when it's on a bridge CMM. However, for sheet metal applications or plastic parts, things like that, that is well within the tolerances that most people need to deal with. 8 to 12 microns is roughly like 0.4 to 0.5 thou or so, like 4/10 or 5/10 or so. It collects a immense amount of data, about 2,000 points at 300 hertz, so that's about 600 points per second across the entire line that it will sweep when it goes across. So a lot of data is captured. You can create hundreds of thousands of points every second. And it's also going to be compliant with your various ISO accuracy standards as well. So a really neat laser. Hopefully you were able to learn a little bit about it. If you had any questions about it, please put those down in the comments and let me know what type of sensor you want me to dive into next for your CMM.